Okay, today we have an 820-3476 from a 2013 A1502 that does not turn on. Now, this board does not appear to be liquid damaged and there is no power. So let's try and figure out why this won't turn on. So as always, before I start using my brain, I just like to look at the board. So we're going to look at the board under the microscope and see if we can't see any like little cap that looks off, or maybe a chip that has a little bit of corrosion near it that we can't see with our bare eyes. So let's go ahead and do that, and let's look under the microscope. Alright, so here's our board. Let's start looking around. I always like to do this first. I can't stress this enough, just so we can avoid using our brain. We don't want to have to measure anything if we could see the obvious problem with our eye. So here is our CPU vCore controller. Nothing looks bad over here. I don't see any liquid on this board. This board actually looks perfectly fine. Let's look at our CPU Mosfets. I don't... actually... No, it looks like just flux. So I don't see anything. This is kind of strange. Never seen one of those there before. What even is this? What is this? That's gross. I have no idea what that is, but it's kind of strange. Otherwise, I don't see anything wrong with this. So what I'm going to do now is start measuring some power rails. So first rail I want to check, since we know we have a green light. So if we plug this in, we have a green light in the charger. Plug it in again. So if I plug it in again, I know I get a green light. So I know PB3V42 is present, but the thing isn't turning on. So what I'm going to do, I'm going to measure PPBUS G3 hot. So PPBUS G3 hot. Moving my meter over here so you guys can see. So here's our meter. Right here, PPBUS G3 hot is going to show up on some of these caps near these CPU Mosfets. That is 0.75 volts. Now that is not good. So 0.75 volts means two things. Either the ISL is not producing the right amount of voltage, or it's being pulled down by a short. So I'm going to check for a short now. So move our multimeter to voltage mode. To diode mode. Which we have here. I'm going to check for a short on PPBUS G3 hot. And we have a dead short to ground on PPBUS G3 hot. Now, what can cause this? Is that a dead short? Yes, that's a dead short to ground. Now, one common thing to fail is the CPU Mosfet. So what the CPU Mosfet will do is the CPU Mosfet is going to short PPBUS to vCore. Now, vCore is typically going to be like 15 ohms on this board. No, it's Haswell, so maybe a little bit higher. Now, this is a dead short. So what I could do is check continuity to vCore. So what I'm going to do is I'm going to check continuity to vCore. And I see I have 0.0 volts. Now, it is very rare for a CPU to die where it has 0 ohms to ground unless it is really badly shorted. That can absolutely be a possibility here, but more likely what's going on is there's a cap shorted on CPU vCore. So what we're going to go ahead and do is inject a very, very small amount of voltage, less than half of a volt, and see if anything gets hot around the CPU or near our CPU vCore circuit. So let's go ahead and do that now. Now, I cannot stress this enough. If you have a PPBUS short that you do not know if you do not know if you don't know if it's being shorted to the CPU, do not put 8 or 12 volts there. Start at half a volt and go up to like 1 volt until you know for certain that voltage isn't being sent to the CPU. Because when voltage, so here's the thing, the regulator for vCore can't really supply enough power to damage the CPU too much. If you inject voltage, it's dead, it's gone. Don't even try. But if you haven't injected voltage, there's still a chance that the CPU can still be okay. I've had Haswell CPUs have shorted Mosfets and they're fine. Okay, like I said, we're starting low. I'm at a half of a volt. We'll go up to like 1 volt, but no more than 1.8. So vCore is 1.8. You do not want to exceed 1.8 because if you have a short to your CPU, we do not want to pump more voltage into that thing and kill it, because the CPU is likely to die if we do that. So let's go ahead and do that. So half of a volt on PPBUS. We are going to solder a wire. Let's get a little bit of flux in here. Solder a wire right here. Here's our DCPS lead. Come on. There, that's soldered. Let's attach this to ground. That area is going to be fairly hot right now, so we may want to wait for that to cool. Now we're pulling around an amp at that, so that's not really hot enough for anything to get hot. But we're going to grab the FLIR and look, because the FLIR is a lot more helpful than our eyes. And it looks like... can't really tell. I'm going to go up to 1.5 volts. So now we're pulling 3 amps. Now we're talking, and we could clearly see we have a short right here. So I can't, you guys aren't going to be able to see this on the FLIR, but I can. And that Mosfet is getting to 125 degrees. Now that's pretty warm. So let's grab a little alcohol so I could show you guys. Because you can't see on the FLIR, obviously. Wish you could. But put a little alcohol down there. See that? So that FET's getting pretty hot. So, let's kill voltage to it. Obviously our CPU is going to get hot because we're putting voltage into it, but we shouldn't have exceeded too much. And so it seems like it's more of, the power supply is maintaining, well, I guess 3 amps, it'll go through it. But I think we're okay. So now what we have to do. Now you may think, well, easy, let's change one MOSFET. No, you can't do that. So if one MOSFET failed, the controller is going to be dead, and the controller is going to most likely have killed all of these guys. So we have to replace all 4 of these, plus the controller, and let's pray it works, because these CPUs don't really like spikes like that. But we will see. We're going to give this a shot, and we'll see if this board can be made happy again. Okay, I'm going to add a little bit of flux just to help taking these guys off. Helps a little bit. Let's get our hot air on. Now we're leaving the heatsink on the CPU. We don't really have to worry about burning it. It's further enough away. It'll get it hot, but it shouldn't be hot enough to damage it. Preheat this area a little bit. Then we can move in and take these guys off. Take all 4 of them off. Almost there. Come on. There's 1. There's 2. There's 3. And there's 4. Those guys are off. Now let's turn the board around to get the controller. I'm gonna get rid of these FETs. Put these right here. Controller is right here. This is gonna be dead too. This is an ISL 958 26 HRZ. That's off. Let's go ahead and clean up this lead-free junk. We don't like lead-free solder here. So we're just going to feed some leaded in here, and what this is going to allow us to do is wick away the lead-free stuff easier. And Amtech NC560 also wets lead-free, so it actually makes wicking easier if you use it. 559 doesn't contain a lot of the additives needed for lead-free soldering, so having a flux that is compatible with lead-free alloys definitely helps in this process. Let's focus that camera since that went out of focus a little bit. This is your average QFN package chip. Nothing too difficult. Now some fresh solder. We don't want too much on the center pad, but it's unavoidable to get some there. You can always remove that after. Right now I just want enough on the pins, and a little bit too hot for this tip. So this is a huge tip, and with a huge tip you're going to burn your flux quicker. So lower your temp a bit. Whatever, we'll just wick away the center pad. Later, I just want enough on the pins. And that's probably an NC pad, but we can check. It could have been an NC pad, or the chip kind of could have exploded right there and burned that pad. We will check. Either way, wouldn't be difficult to run a wire to, but I'm 99.9% sure that's just an NC pad. Good on that center pad. Let's clean up this flux. You could solder it with old flux, but I don't really like to. You risk, there is a higher chance of bridging with old burn flux than with fresh, but it's not too big of a deal. And let's look. I don't see anything connected to that, so that is an NC pad from what I see. Just put some new flux down. And grab our chip from the donor board. So the chip from the donor has flux around it already, so that's, yeah, let's grab a different one. Because if this had flux on it from China or wherever it went from, I don't really trust that chip. That chip is likely to be dead. Could have been one we soldered to, but... Or it could have been one that we tried, didn't work, and then put it back on. But either way, I'd rather go with this one that has not been touched, so I'm going to pull this one off. So our donor chip. See, QFNs are kind of cool. They'll pull themselves into place like that. Kind of like BGA. They just pull themselves into place if they are aligned. It just takes a little bit of feel to get to solder them, but after you've soldered a few, you should be good to go. Now we're going to apply some gentle pressure on it. The reason for that is to get rid of all the excess on that center pad and to push the chip down so that the all the pads are seated. That should be good. Let's let that solder dry. I'm going to change this tip to my J-tip because I like my J-tip for soldering QFN a lot better than this BC2. The BC2 is an excellent tip. It's big, but you could turn it to get into tight places, but nothing comes close to my JSO2. The JSO2 is just simply awesome. It's like it could be used for anything. It's perfect. There's no better tip in the world than the JSO2 after it gets hot. It's perfect to get into places like this where you need to feel each pin. Should be good. Now we have to solder our Mosfets. So these guys are easy to solder. Just a 4-pin package. Well, it's a 4-pin plus a big one. But let's clean up all that lead free. You don't really have to do this, it's just habit for me. It's kind of unnecessary, just flux, but whatever. We're here, why not give it a fair solder? You don't have to give it all of it as went out of focus there. That should be good. Add more flux because we're gonna burn a lot of this off. Putting that first one on, just how it is. You always burn that flux off. Make sure you get your MOSFET orientation right. You wouldn't want the thing to explode. It's kind of hard to solder that MOSFET backwards, but yeah, it happens. If you've ever seen a QFN chip placed where a BGA chip goes, it happens. Sometimes this industry will surprise you on what people will do. So MOSFET 1. Come on, go into place. Into place. MOSFET 2. Want a little bit more flux here. Hopefully this CPU isn't dead. This is pre-recorded and I'm not being wished bad luck by anyone in live chat, so maybe this thing will be alive. Anytime anyone says dead CPU in live chat on live streams, it always comes true. So yeah, if you say dead CPU, you will almost always get your way. Into place, come on. Come on, there you go. You're into place, all those guys are in place. Now, here's a way to know if our CPU is dead. Well, after it cools, you never want to turn on a board or anything with a silicon chip that has millions of transistors on when it's hot, for a couple of reasons. When silicon is hot, the resistance to ground and voltage leakage is going to be much higher than when it's cold. So if we turn our CPU on when it's at 200 degrees Celsius, it could fry. So what we want to do is let this board get nice and cool. So what I'm going to do, I'm going to put this on my fume extractor so it gets good airflow around that CPU to cool it, because it's burning hot right now. And then after that, we'll turn it on, and we're going to check resistance for turning it on. So CPU resistance. So CPU resistance to ground is going to be based on the voltage leakage to ground that the chip is producing. Lower, more of a voltage leaky chip. Higher resistance, less voltage leakage in the chip. Now, any CPU is going to get more voltage leakage over time as it ages. This is accelerated by heat through a process called electron migration. look into that. I don't know everything about it. All I know is it happens, and when a chip has more voltage leakage, the resistance to ground is lower. So this is still pretty hot, but let's see what we have in resistance. So minimum 5 ohms. Minimum 5 ohms, I would say. And we have 20 ohms to ground, and the board is hot, so there's a very good chance the CPU is still fine. So let's see. Let's plug it in. I think we're good. 20 ohms. Yeah, that's fine. That's fine to turn it on. Let's see if I have fan spin. Let's see if I can leave the store at 10 o'clock on a Friday, whatever today is, Monday night, with a fixed board or a dead board. So let's see. Here's our fan. Wait. Here's our fan. Here's our MagSafe. Let's plug it in. Green light. Do we have green light? Green light. Fan spin. Now let's see if it posts. So this is pretty cool, and I'm gonna, there's a certain person that I'm gonna send this to show him, say, hey, look at this, it's shorted CPU MOSFETs, fixed board. Show him who gets a dead CPU. Alright, let's put this back in the enclosure real quick. And let's see this thing. Now, here's the thing. We could be getting trolled. This thing couldn't post. Maybe it won't post. But let's see. We're going to put it back in the enclosure, and we're going to see the truth if we get a dead CPU or not. But our high side MOSFET was shorted. I need to clean that mess. Where's that? Oh, here it is. Looking all over the place for my enclosure. Okay. So here's our MacBook. Here's our board. So we at least know for us to get fan spin, we know that our PMIC inside the CPU is working. That's a minimum. We know our PMIC is working. The PMICs on these are integrated into the CPU. Well, the PCH. The PCH is integrated into the CPU now, and the PMIC is integrated into the CPU, into the PCH. So these are more like SoCs than anything. Haswell was kind of the last year that I like Intel. Broadwell is Skylake is awful. Skylake is absolutely awful. Just failure-wise. So screen. Plug in a screen. Speaker. Let me, you know what, let's grab an SSD too. Do I have an SSD around here? I do have an SSD. Plug in an SSD. Our DCN board is not seated all the way. Push that thing over. So if your DCN board isn't lined up completely, you will not get power. Let's move this over. Should be good enough, I think. We'll make contact. Getting the DCM board over so it's in a little slot is probably harder than the whole board repair. But we have an SSD plugged in. We should be getting fan spin here. We have fan spin. We have chime. We have chime and maybe Apple logo. Apple logo. Come on, please. Please, Apple logo. Well, it posted, so we're mostly good. And our DCM plug came out because I moved the board on the table. So now we have to wait all over again. But hear that chime? That's the chime of success. We also have backlight, but I don't want to show the thing because, you'll see the customer's info. We don't want that. It doesn't recognize the drive, so it's going to take a minute to boot, but this should boot and this should be fixed. Just give it a minute. Or the drive I plugged in could be dead. You never know. Never trust a random SSD from TCRS circuit that's been sitting in a bin over there, because you never know. It's probably dead. There we go. The logo. Oh yeah, the trackpad is unplugged, so it's gonna boot slow for the sensor, but yeah.